And it's a Wednesday night, and I missed you guys last Tuesday, so it's week 2 of Bio 1140. And this is our Themes in Science chapter. And if you've noticed, if you're in my class, that, well, I took down the PowerPoint and the required reading this afternoon, but I'm going to put it back up in about an hour or two. I'm undergoing a fairly big rewrite. I got a student that asked me a pretty good question. He goes, I have a hard time finding some of the answers, and I was like, oh, I thought they were pretty straightforward. Went back through the quiz and the PowerPoint and the reading, and I've realized that over the last year or two, I've made some changes to the material, and they didn't align as well as I thought they would. And I'm rewriting all this material so that it all aligns much better. So the PowerPoints will align with the reading, and that will align with the quiz. So very briefly, this week is really fun. I mean, we start off with talking about what is life and understanding why it's important and how we define life for how we think about the importance of it for things like, well, am I looking for the origins of life? Am I looking for life on planets? Or for biology, for health-related sciences, are we thinking about physiology and homeostasis? So our definitions of life really inform us in terms of how we think about life and what aspects of it are important. And that's a part that I'm actually rewriting right now. The other thing I talk about with life is also an emergent property and the hierarchy of life. And, traditionally we just talk about this emergent properties, that life is this complex system that has new properties every time you go up in complexity. So a way of thinking about that is, imagine you have two gases, oxygen and hydrogen. You put them together, you get H2O, you get water. Water is an emergent property. It's liquid at room temperature, where oxygen and hydrogen is a gas. So that's an emergent property. In life, properties that arise at the level of life that we can't always predict based on knowing all the individual properties of us. So I can study cells, but that doesn't mean I know exactly how you work as an organism. And those emergent properties are really important, because that's why it's so hard for us to figure out things like aging. That's why we haven't treated all forms of cancer, or we still don't understand consciousness, right? I mean, wow, consciousness, talking about the ultimate emergent property of the universe, right, is our consciousness. And so understanding that is really difficult because it's an emergent property. You can't predict the emergent property knowing it's what has made it, knowing all of its components there. The other thing we talk about here is also life is actually connected to the earth. Life interacts with your environment. And the reason why you interact with your environment is, well, you need resources. You need food. You need energy, building blocks to, make cells. And so life has to interact with the environment to get that. And if there's something wrong with our environment, that might affect our food supply. And of course, it also goes to show that I love meat. Don't get me wrong. I love elk and steak and chicken and fish, but eating that is it's not the most efficient way to get our energy, because as you'll learn from how life interacts with the environment is that you lose most of your energy as you go up in food levels. Okay, it looks like I'm reconnecting. How am I doing there? Okay, I think I'm back. So at any rate, the other thing I talk about in this chapter is that life evolves, which has a lot of implications for us. And I talk about how evolution is the central paradigm of biology and why that's important. Like, for instance, think about this. How many of you have back pains? Well, you're young. I hope not too many, right? Back pain, knee pain. Well, that's because humans and our ancestors have only been walking upright for 5 million years, 7 million years. And the whole history of vertebrates, going back over 500 million years, that's only 1.5% of our time have we been walking, upright. We haven't had time to figure out all the kinks with backs and knees. And then another problem is also something I'm talking about now is humans evolved as a hunter-gatherer over the last 200,000 years. It's a lot of moving around, walking around, eating berries, nuts, fruits, lean meats. Well, today, what am I doing? I'm sitting down at my computer. I've been most of the day eating yummy food from the refrigerator. There hasn't been much hunting and gathering on my part except walking over to the refrigerator, going back to my desk, and eating. So my non-mobile lifestyle here with lots of calories, well, this has led to problems with humans of obesity, vascular disease, type 2 diabetes, right? We've got all these problems that have associated because of our bodies haven't evolved to deal with our new lifestyle of being less active and more calories. So these are the themes in biology that we're going to go through in this chapter. So I'll have this posted later tonight. I'm almost done with it. I'm just rereading it. It turned into I was just going to make a couple minor changes and ended up cutting a lot of stuff out and adding new stuff. But I think it's much better, much more relevant to you guys. Because when I started doing this class, I added in a lot of stuff that I liked, that I found really interesting, but may not have been quite as relevant to biology for health-related sciences. Okay, now, the next thing I want to do is answer your questions. Okay, so we've got, a quiz that's going to be due. Don't worry, I'm going to extend the due date because you didn't have today to work on it. But if you've got questions, you can hit me up on the top chat. And if I don't see any questions right now, I'm going to go through the questions I've gotten from the discussion last week. I haven't gotten any questions this week, so we'll start with last week. It turns out that in chapter 1, one of the biggest things that people are having a hard time with was correlation versus causation. Okay, correlation. Two variables, they move together. Okay, so I'm going to read this here. And if two variables are moving together, they can be independent of each other, or one could depend on the other. So let me give you some examples here. Well, before I give an example, causation is when one change in one variable causes another variable to change. Okay, let me give you an example here. Here's 3 examples, ranging from completely random to one completely depends on the other. Here's a good one. Average global temperatures have increased as the number of pirates have declined. Okay, here's a second one. The number of deaths by drowning is correlated with ice cream sales. So when there's more ice cream being sold, there's more death by drownings. And then the last one is, number 3, active studying several hours a day is correlated with higher grades. Okay, so the first one, average global temperatures going up as pirates go down. That's a correlation. They're completely independent of each other. The number of pirates in the world has no effect on global temperatures. Burning of fossil fuels, methane from cows farting. Yes, methane from cows farting is a real thing. Methane from termites farting too. Methane from organic matter breaking down in the Arctic. All of these are contributing greenhouse gases to the atmosphere, which is causing global warming. But in this case, the pirates have no effect on climate. None. So even though they appear to be correlated, it's just random. The next one. The number of deaths by drowning increases as ice cream sales go up. Well, ice cream sales clearly have no effect on drowning. However, in the summertime, more people go swimming. And if you have more people going swimming on swimming pools, and sadly, there's some deaths of people in swimming pools, but it's also warm. More people eat ice cream. So in that case, there's a third variable, summertime temperatures, that is actually driving the other two, ice cream sales and drowning in pools. Then the third one, active studying. Several hours a day is correlated with higher grades. Well, if you don't study, you don't do well. The more you study well and efficiently, the higher your grades. In that case, grades is the dependent variable because it depends on how much you study. Okay, So I hope that explains correlation and causation. So the first one, pirates and climate change, completely independent. The second one, deaths by drowning correlated with more ice cream sales. There's another variable affecting those two. And then active studying is correlated with higher grades. We say that is a causal relationship. Grades is dependent on studying. Okay, I had a couple other really good questions in here. One was, let's see here, correlation, causation. One I had trouble understanding was the anecdotal evidence, whether or not evidence is anecdotal. Okay, anecdotal is, it's empty. I know. There's a little bit left in there. Well, there's nothing really. Oh, this one too. Oh, this one too. Oh my gosh, it's a graveyard around here. Diet Pepsi bottles. Anecdotal evidence. Every day I drink Diet Pepsi, I don't get sick. Yeah, right. That's pretty silly, isn't it? Every day I drink this, I don't get sick. Well, what's going on here is I'm just lucky that I haven't gotten sick yet. I try to stay healthy. But this in no way has any type of effect on me getting sick. So, but an anecdotal evidence is one form of it that would be wrong, incorrect is, hey, I drink Diet Pepsi a day. That keeps me from getting sick. That's, of course, anecdotal evidence, and we know it's wrong. Other types of anecdotal evidence that you often hear, coming down with a cold. Go eat more vitamin C. Go take more citrus. Get more vitamin C. Take some zinc. Get rid of that emergency stuff that you can buy at the store to help ward off the cold. Lots of people swear by it. Sadly, I wish it worked, because every time we've done the experiment to see if it works, if it prevents people from getting sick or actually reduces the amount of time that they're sick, it doesn't really work out. So that would be a personal experience, like a variable of one. My experience with diet soda not catching a cold. Somebody who eats an orange and says, I didn't get sick, or it made me get sick faster. These one or two observations are anecdotal. Okay. Now, sometimes anecdotal can be correct. Anecdotal evidence is, I lost 20 pounds in 2022 because I went to intermittent fasting, which means I eat between 10 a.m. and 6 p.m. And I lost 20 pounds. That's anecdotal evidence. And interestingly, if you read about intermittent weight loss or intermittent fasting and weight loss, the new evidence is showing that it doesn't cause weight loss. Well, what they're not telling you is a couple things. One, it has this enormous impact on your body in terms of the way genes are regulated that can extend your longevity, help ward off disease like cancer. And for me, as anecdotal evidence, one of the reasons why it led to weight loss is because I didn't eat breakfast and I didn't eat after 6. And as a result of skipping out on breakfast and not eating after 6, I cut my number of calories down. I ate less. I lost weight. Imagine that. So, but my one example of intermittent fasting leading to weight loss would be anecdotal evidence. And if you do intermittent fasting and you don't control calories, most people won't lose weight. Okay. But we do know that if you do a large controlled experiment and you get people eating less food, just eat more healthy and less of it, then we often get weight loss. And when we have lots of people doing this in a controlled experiment, then we move from anecdotal evidence to, yeah, this is actually real. So let me know if that helps out there. Another person talked about, what is entropy? Entropy is an important concept in physics, and entropy governs energy transformations. And the first law of entropy is you can't create or destroy energy. But the second law is what gets us every time. The second law of entropy says that every time you use energy, that energy becomes degraded, means it becomes less usable. That has a very important implication for life, because life needs energy. Without energy, there can be no life. And we use energy to maintain homeostasis, to grow, to reproduce. Everything we do requires energy. But because we cannot recycle energy, we have to have a constant flow of energy through us. Okay, so life, that's part of our connection to our environment. We need a constant supply of energy. We have to extract energy from our environment. And because energy is lost every time you use it, as you go up in feeding. So if I have a cow on a field and I have, let's say, 100 kilojoules of energy, and a cow comes and eats that 100 kilojoules of energy, only about 10 go to that cow, 10%. And if I eat the cow, only 10% go to me. So from the grass to me through a cow, I only get 1% of the energy that was in that grass. So as you can see, eating meat, pretty inefficient. I'm not telling you to go be vegetarian or give up eating cows. I'm not saying that. It's just something to be aware of. Okay. That would be entropy. Don't worry about how we measure it. Causation. Okay. Another student said I had a difficult time understanding when to reject or accept a hypothesis based on significant difference. Okay. This is important. In science, we do what's called hypothesis testing. So we formulate a hypothesis that we can test potentially and potentially falsify. That's part of our philosophy of how we do science. So let's say I wanted to do something like test whether or not 30 minutes of cardio 3 times a week causes weight loss. Okay. And then we want to say significant weight loss. That's not the amount of weight you lost, but that the change in your weight is statistically not random, that the cardio caused the weight loss. Okay. So let's say you do your experiment and you take people for 3 months and you have a control group that does no cardio. And then you have your experimental group that does cardio 30 minutes 3 times a week. You put them on the regimes and you come back, you weigh them before and after their weights, before and after the treatment, of course, being cardio for 3 months. And then you look at the average weight of each group and you compare the average weight and the amount of variation in that group. And what we've learned from decades of, well, since the 90s of doing this kind of experiments, believe it or not, cardio doesn't cause weight loss. Now, it does cause lots of physiological changes that are all very, very beneficial to you. Even though your weight might not be going down, it's still having a tremendous positive effect on your body. So don't just focus on the scale. Focus on, your exercise. Even if you're just getting up and walking around. I've walked around my house about once an hour today. Just that 5 minutes of just walking around is helpful. Okay. The reason why those differences are not significantly different is because even though you might have a pound less over here in your experimental group that did the cardio compared to this one, the average weight change may have been minus 1 pound plus over here 0.5 pounds. The amount of variation was so high, there was so much overlap that any difference between the two groups is due to random chance. You don't know that the cardio actually caused that. So in that case, we would not reject our null hypothesis, which is the hypothesis of no effect. And that would be cardio has no effect on weight loss. We failed to reject it. So we have to accept it. I know that's really weird. That goes so counterintuitive. Even I, for decades, was like, yeah, cardio causes weight loss. That's how you lose weight. You can. I mean, I lost weight doing it, but I hiked 5 miles a day, like 5-6 times a week, like every morning before I went to work. I lost weight. However, when you reject the null hypothesis, let's say we took we took 2 groups, control group, no change in diet, and we took the experimental group and we put them on a high plant-based diet with 30 minutes of cardio. You come back after 3 months, guess what's going to happen? If you control diet and cardio compared to your control group that you did not, then they do show like -5 pounds over here to basically no change in weight. In that case, the difference is significant due to your change in your diet. In that case, we would accept lower calorie plant-based diet with does cause weight loss. However, just for you guys at home, you at home, just changing your diet up is often enough to start causing weight loss. So that's how we know when to accept or reject a null hypothesis, is based on significance. It's not the amount of change, but it's whether or not that change is due to random chance or not. And we start with, like I said, our null hypothesis. No difference. Cardio causes no change in weight. Diet has no effect on weight. And if we can reject that and say, yeah, it's likely diet causes weight loss, then we'd reject the null and accept our alternative hypothesis. And that's a way that we do science. That's one way we do science. Okay. Another student asked how entropy increases or decreases. I just went over that a few seconds ago. Entropy increases every single time you use energy. So, and you decrease it by doing work. Think about it this way. Think of your house or your room or your dorm or wherever you're living. Imagine you never cleaned it. You never cleaned your kitchen. You become more and more disordered. It looked like my office behind me. I mean, there's some order to it. There's also a lot of disorder as well. The reason why is because the universe grinds toward entropy, grinds toward this stable state of equilibrium where things are just out of equilibrium. Everything is just kind of chaotic, static state. But to reduce entropy, you have to do work. I have to get up out of the seat and go start picking up things and putting them in their place. I have to go clean the dishes, let them dry, stack them back in the cupboard, take all of my spices, organize them. I'm doing work. I'm using energy to reduce entropy. And that is also, when you read chapter 2, and I get it back up there for you, you will learn that life also uses energy to do work. Life uses energy to basically create a system that's out of equilibrium with the environment. I'm way out of equilibrium with my environment. It's like 70 degrees in my house. I'm 98. I'm highly ordered system. I try to be a highly ordered system, right? Whereas the air around me is completely chaotic. Okay. And it takes energy to do that. That is that going back to that connection of why life needs energy. Okay. Null versus alternative hypothesis. I'll do this again because this is a really important thing. And when in physiology or in biology, whenever we test something, we test against a null hypothesis. A null hypothesis is basically that hypothesis of no effect. Cardio has no effect on weight. Doing strength training, like bench pressing, has no effect on muscle mass or your 1 rep max. This would be a null hypothesis. Diet has no effect on your weight. Exercise has no effect on your weight. These are null hypotheses, the hypothesis of no effect. An alternative hypothesis, that's what we're really trying to get at. Diet causes weight gain. Diet causes weight loss. Exercise causes weight gain. Exercise causes weight loss. You get the idea. That would be the alternative hypothesis. Okay. Correlation, causation, null hypothesis, and the roles of different variables. Okay. When we talk about different variables, what we normally talk about are the dependent and the independent variables. Let's go back to weight and exercise. In this case, even though we've already talked about the null hypothesis is that exercise has no effect on weight. In this case, exercise would be the independent variable. Weight would be the dependent variable. So we're going to assume that weight depends on exercise. When we test for it, of course, we find it doesn't have a weight. We could also talk about diet. Diet being the independent variable and weight being the dependent variable. And in that case, diet absolutely does affect weight. So in that case, there's a causal relationship there. You eat more food, more calories, especially refined food that's really highly processed, it's likely to drive your weight up. Go to more plant-based diet and less of it, your weight will likely come down. Likely. There's some variations in people. Okay, so that's the difference in the variables. All right. So does anybody have any questions on the top chat? I believe it's available for you guys if you have any questions. If not, thanks for coming out. And I'll sign off and have that chapter up and ready for you. And we'll do this again next week. Any questions out there? All right. Well, thanks for joining in. And yeah, this will be available on Canvas. All right. Till next week. How do I stop? There it is. Oh, not yet. How long would the extension be for chapter 2? Oh, I'll probably just give you a week extension on it. I'll just probably make it do the following Sunday. You have plenty of time to get caught up because I don't know if today was like your day to do. Man, I'm slammed from now to through next week. I don't want to have. I took it all down, but I'm making a fairly big. Okay, we good? Any other questions here? All right, you're welcome. Absolutely. All right, I'm signing off.